Welcome to the demonstration of my project Malware Insight. Let me begin by showing you the YARA rules that form the foundation of a signature-based detection. Here is in the YARA rules folder, we have the rules.yara file containing 8 carefully crafted rules. These rules detect various malware characteristics. For example, this rule detects packed executables for looking for files larger than 10 kilobytes and with entropy exceeding 7.2. Each rule includes metadata specifying the severity level. And here we have the feature extractor. Next, let me walk you through the feature extractor module. This file contains the code that extracts lightweight numeric features from uploaded files. The calculate entropy function implements Shannon entropy, which measures randomness in file data. Higher entropy often indicates packed or encrypted content commonly used by malware. And for the index.html, in this front-end interface built with HTML, the index.html file structures the user interface with navigation bar and the analysis forms. The drag and drop area allows user to upload files by clicking or dragging directly into the browser window. There is also a toggle switch that lets users switch between file scanning and URL checking modes. The interface includes feature cards that explain the system capabilities and function and technological section that walks users through the four-step analysis process. The design is fully responsive, ensuring a seamless experience across desktop and mobile devices. And the heart of the system is main.py, which implements the fast-end API development. The upload endpoint and handle file uploads. It computes the SHA-256 hash. For new files, the system proceeds through an analysis pipeline. It runs the YARA scanner. The final report includes the hash, YARA matches, anomaly score, and verdict, resource metrics like CPU usage and memory consumption, and execution duration are also captured and returned. In this Jupyter notebook contains a deep autoencoder model training code. During training, the model minimizes the mean squared error between input and reconstruction. After training, we compute reconstruction errors for all Benning samples and set the anomaly threshold that captures 95% of them. This approach enables detection of zero-day malware without requiring labeled malicious samples for training. And next, the style.css file. This defines the visual appearance of the front end. It implements a modern design with gradient background, mass glass morphism effects, and smooth animations. The feature cards have, however, effects that enhance interactivity. The color scheme uses dark backgrounds with accent colors for buttons and icons, creating a professional and trustworthy appearance suitable for a cybersecurity application. The metric cards display resource usage with clean typography. The drag and drop area has a subtle border animation that indicates readiness of the system file. And the URL analyzer. This is the URL analysis model. It evaluates web links for malicious characteristics using heuristic indicators. The This model helps protect users from phishing attacks, and malware distributions. And now let me demonstrate the system in actions. I'll start by navigating to the Malware Insight dashboard. The home page displays key statistics and 99.5% is rejection rate. Now in the analyze section, here I can upload the file by dragging and dropping or clicking the select to select. I select as a simple file for analysis. Notice that Yeah, notice that as soon as I select the file, a preview appears showing the file name, type, and size. I click the Analyze button. The system is now processing the file. It computes the SHA-256 hash, runs YARA rules, extracts features, and passes them to the autoencoder. Yeah. Now, below the result, we can see the resource metrics, the CPU usage, the peak memory, and the peak memory consumption, and in megabytes. These metrics provide transparency about computational cost of each analysis for security teams. Now, finally, let me demonstrate the URL analysis feature. I'll switch to URL checker mode and enter the test URL. Yeah, I'll click the check URL. The system processes the URL and returns the results. Here, as we see, the risk score of 1 and a reason explaining URL length usually long and with the verdict safe.